Second example on the page. Now we have a bit more of a polynomial going on. F of x is x cubed plus 4x squared minus 5x plus 6. So it's a cubic function, and we're interested in the derivative. It's going to take a little more work, a lot more space. So I've kind of started this off already. We have our general form of the derivative right there. The limit as h approaches 0 of f of x plus h minus f of x all over h. And we are going to plug x plus h into our function. That's what you see right here. X plus h being cubed, 4 times x plus h squared, minus 5 times x plus h, plus 6, and then we subtract the entire function. Again, notice that we have the minus sign around the entire function. Okay, so we have a lot of algebra going on here. Now, in a previous video, we expanded out x plus h cubed. Okay, that came out to be x cubed plus 3x squared h plus 3xh squared plus 1. Okay, so you can check that previous video as example 1 from back from the previous lesson there. We have that expansion right here. Then we have 4 times x plus h squared. Now, order of operations says we have to do the exponent and then multiply the 4. If we do the exponent out, that means we're expanding the binomial. So that's x plus h times x plus h. We've done that as well in a previous example. So x plus h times itself. Let me change colors here real quick. This will be, this 4 is still out front, and x plus h times itself is x squared plus 2xh plus h squared. Okay, so when we distribute, oops, that should be, there we go. That 4, when we distribute the 4, we're going to have 4x squared plus 8xh plus 4h squared. Okay, so this second term turns into that trinomial. Then we distribute the minus 5, so minus 5x minus 5h, and we still have our plus 6. Okay, getting low on room here, so I'm going to make my fraction bar even larger. I told you this would take up some space. Now we have to subtract the entire function, so we're going to distribute that negative sign just like we did in the previous problem. So we're going to have minus x cubed minus 4x squared plus 5x minus 6. That's my entire numerator. Let me get out of the picture so we can see the whole thing. That's what happens when we do all the algebra out, and that's all over h. Okay. Now, believe it or not, if we plug in 0 for h, this is still going to become 0 over 0. So we got to get rid of this h. We can't do that unless all of the non-h terms cancel out. So take a second, pause the video if you need to, see if they all cancel out. I'm going to do the same thing right here. X cubed minus x cubed. And then we have, oops, this should be an h cubed right here, not 1. And then we have 4x squared minus 4x squared. And then we have minus 5x and plus 5x. And then we have plus 6 and minus 6. Okay, so the only terms that are left should be h terms. All right, and it looks like that is the case. So we have the limit as h approaches 0, h term, h term, h term, h term, h term, h term. That all cancels out. So since all the terms remaining in the numerator have an h, let's factor that h out. Okay, so we're going to factor the h out. And I'm going to write the leftovers. 3x squared h divided by h is 3x squared. 3xh squared divided by h is 3xh. H cubed divided by h is going to be h squared. 8xh divided by h is going to be 8x. 4h squared divided by h is going to be 4h. 5h divided by h is going to be 5. Everything else canceled out. We still have an h in the denominator. Now that we have the h isolated out front, they can eliminate each other, and we can plug 0 in for all the remaining h's. What happens when we do that? Well, we have 3x squared, and then we have 3x times 0. So that goes away. Right? Well, I'll just put in a plus 0, but we don't really need it there. And then we have 0 squared. So that also is not necessary. Then we have 8x, and then we have 4 times 0. That goes away. And then we have minus 5. So if we get rid of all the zeros there, we have 3x squared plus 8x minus 5. And that is our derivative function if the original function was that cubic up there.